Hello everyone, this is Vijay Lakshmi Sugnalli and this is my YouTube channel When Maths. Here this YouTube channel helps to those which are studied first PUC NCERT syllabus. I solve the example problems, exercise problems and related theory based on the syllabus and topic wise syllabus. Here in this section we discuss the concept sets. Here sets. The concept of sets serves as a fundamental part of present day mathematics. Today, this concept is being used in almost every branch of mathematics. Sets are used to define the concepts of relations and function. The study of geometry, sequences, probability, etc. requires the knowledge of sets. Okay, basically, the theory of sets was developed by the German mathematician George Cantor. The great mathematician George Cantor. He was developed the theory of sets. Okay, this mathematician George Cantor was developed the theory sets. He first encouraged these sets while working on the problems on trigonometric series. Here in this chapter we discuss the definition of the sets, and based on the definition we have discussed the basic operations of the sets. Okay, here in our daily life we are used many of the examples and results. Okay, then the definition of set is basically the definition of sets is well defined collection of objects. Sets is a well defined collection of objects. Here well defined, okay, here well defined means all are obeys. Okay, all are obeys. It means universal truth. Okay, all are obeys means or it is universal truth. Well defined means universal truth. They can accept everyone. Okay, the meaning doesn't change in every way. Okay, that is sets is a well defined collection of objects. Here the some points are discussed on the sets. Usually the sets are written in capital letters like A, B, C, X, Y, Z, etc. Okay. Usually sets are denoted in capital letters. Okay. The sets are denoted in capital letters, and the elements which are present in sets. Okay. The elements which are present in sets are denoted in small letters. There are A, B, C, D, E, F, etc. Okay, the elements are usually denoted in small letters. Okay, small letters. The elements are usually denoted in small letter. Sometimes these are called as members also. It may be called it as members or elements or objects. Okay, then sets are usually written in a flower bracket. Okay, let sets are usually written in a flower bracket form. Okay, here consider an example, that is the example. Okay, here n is the set of natural number. Here in number system we may give some more examples. Okay, the capital N always indicate the set of natural number, set of natural numbers. Okay, set of natural numbers. Then Z means Here z. Z means set of all the integers. Set of all the integers. Next, q. Q means the set of all rational numbers. The set of all rational numbers. The set of all rational numbers. Okay. Here I am taking one example. Here A be a set, then A B C D E. Okay. Here A denotes the set A B C D E. The small letter A B C D denotes, it can be say that elements or members. Okay, these are called the elements or members. Usually the set represented in capital letter and the elements or members are written in small letters. Okay, next there are some mathematical symbols. Okay, there are some mathematical symbols. Mainly this symbol denotes belongs. Okay, this symbol denotes belong and this symbol denotes not belong. Okay, not belongs. Okay. Here I am taking this example. The symbol, this means belongs. Here there is an element A which is belongs in set A. It can be written as A belongs to A. It means A, an element A, that is A belongs to A. A belongs to A. Here small letter A denotes, here the small letter A. Here the small letter A denotes the element and capital letter A denote the set. Therefore, we can say A belongs to A means an element A which is belongs to set A. This is the meaning. Okay. Usually in set theory we written in a symbolic form. Most of the time we written in a symbolic forms. Okay. Again, for not belongs. Here the elements A, B, C, D, E are belongs here. Other than these elements, whatever you have taken. Okay, here I am taking 1. Okay, so 1 does not belongs to A. Here the element 1. Okay, here 1 not belongs to, here 1 not belongs to set A. Here 1 not belongs to A. Okay, there are two types of representing sets. Okay, there are two methods. There are two methods to represent in a set. One is set builder form and another one is roster or tabular form. Okay, here there are two methods. There are two methods of representing set. There are two methods of representing sets. One is roster or tabular. Okay, another one is set builder form. Okay, another one is set builder form. Usually simply what I say, roster. Okay, roster or tabular means list. Okay, roster or tabular means list. Okay, here the roster or tabular means we have to list the elements and write it in a flower bracket. Okay, roster or tabular means we have to list all the elements and write it in under the flower bracket. That is called as the roster or tabular form. In set builder form means have to write in a sentence. Okay, have to write or represent in a sentence form. Here in roster form we have to make a list, and in set builder form we have to write in a sentence. Okay, I have considered a roster form. Okay, here example, let a set a be a let a be a set containing the elements a, e, I, o, u. Okay, the set containing the elements a, e, I, o, u. Okay, this is called the roster form. Okay, and in set builder form, okay, it can be written in a set builder form. I wrote here, this is the roster form. This is the roster form. The set can be written in sentence. That is the set of all vowels. The set of all vowels in English alphabet. The set of all vowels in English alphabet. The set of all vowels in a English alphabet. This is the set builder form. This is called the set builder form. Okay, you have idea now. Okay, the elements are written in a list or the elements are written in a flower bracket. That is called as a roster form. It can be written in a sentence, then it is called as a set builder form. And set builder form can also be written in another type. Okay, the set builder form can be written in another one method, that is it can be written this type is also okay. In sometimes we can't write here in general form. Okay, that's why then a is equals to x, x be any element. I have taken generally x be any element. This symbol represent the semicolon represent in set is such that, okay, that is the symbol indicates such that, the symbol semicolon indicates such that x is a set of vowels, set of vowels in English, set of vowels in English alphabet, set of vowels in English alphabet. Okay, set of vowels in English alphabet. This is also a method of representing set builder form. This is also one of the method to represent in a set builder form. Okay, now here there is a another one point is there. Usually in roster form or any form are written any set, the repetition of elements not taken. Okay, and whatever times the elements are given, but in sets it denotes in single letter. Okay, a, e, I, o, u, all the elements are similar elements written in a once only, and in between the elements there is a comma. Okay, we have to put in between the elements a comma. Usually a roster form or a list form, the elements are written in a flower bracket. Under the flower bracket the repetition of the elements are not allowed, and the repetition is there or not, the elements are written in once. There is a comma in between each element, that is called roster form. In set builder form always it is in the form of sentence. Okay, sometimes the sentence written in this type or in this method under the flower bucket, but that time you should or you must have to written an element x such that, then have to write the general indication. Okay, general indication. Then we discuss the examples and exercise problems. We discuss the some examples. There is a example 1. Write the solution set of the equation x square plus x minus 2 equals to 0 in roster form. Here they given a one equation. Okay, that is the equation x square plus x minus 2 equals to 0. Here it is a quadratic equation because x has the power 2. Here the solution has the x values 2. The system of equation has the two values. Okay, here I simplify this equation. Okay, now first I consider minus 2. Okay, then it can be written minus 2. Okay, so the two numbers which are multiplied, then we get minus 2. Okay, then their sum will be plus x. The number we have taken two multipliers. When multiply those two numbers we get minus 2. When we add those two numbers we get plus 1. Here 2 2 into 1, 2 into 1, 2. Here there is a plus sign, it means 2 minus 1, then we get plus 1. That's why I taken 2 into minus 1. I replace x by x square plus 2x minus 2 equals to 0. Again we simplify, we get the result x square plus x minus 2 equals to 0. The equation can be written in this form. Then we make group. Okay, take x from this equation, we get x plus 2. Here from x square I have taken x common, from 2x I have taken x. Then here there is a minus in between x and 2. I will take common as a minus 1. Okay, then we get x minus 2, x plus 2 is equals to 0. Then make it a 2 group, x plus 2 as common, we left x minus 1 equals to 0. Therefore the system of equation has the two roots, that is x plus 2 equals to 0 and x minus 1 equals to 0. Therefore taking minus plus 2 on right side, it becomes x is equals to minus 2. Here x is equals to 1. And therefore x has the two values. Then they given, we have to write in a roster form. Roster form means have to make a list. That's why I written the solution is, solution of the given question is a set A containing the elements. What are the elements? 1 and minus 2. This is the solution of the given question. Okay, of the roster form. Okay, the set of equation x square plus x minus 2 equals to 0. Therefore the solutions of x are 1 and minus 2. Here there is a example number 2. Okay, write the set such x such that x is a positive integer. Always we have to remember x, the semicolon, x is a positive, it means it is of the form in set builder form. Set builder form means the sets are written in a sentence form. Okay, that's why the x such that this symbol represent the set builder form. They written, we have to written in a roster form. Okay, roster they already given in a set builder form, we have to write the solution in roster form. The condition is x such that x is a positive integer and x square is less than 40. Now taken as x. X means any positive integer. Positive integer means the x values must be positive. X values must be positive. Okay, then such that here there is a condition x square less than 40. We have right or we have taking the positive values here. For example, I have considered x is equals to 1. 1 square which is less than 40. Yes. And therefore the elements are set. A is equals to, the elements are, I have taken x is equals to 1. 1 square will be 1. Again, and there are positive integer. That's why I have consider 2. 2 is also an element. 2 square is 4. The condition will be satisfied. And then x is taken as 3. Here 3 square is 9. Therefore 9 is also less than 40. Next, I have considered x is equals to 4. Therefore 4 square is 16. It is also less than 40. So the element 4. Then x is equals to 5. 5 square 25. 25 is also less than 40. Then the element is 5. Again I consider the element 6. 6 square is 36. Therefore 36 is less than 40. Then I consider x is equals to 7. 7 7 square is 49. 49 is less than 40. No, 49 is always greater than 40. That's why the condition is not obey for other than 7, 8, 9 and up to so on. That's why I consider from 1 to 6 the elements or other numbers satisfy this condition. Therefore the elements of the set A is equals to 1 2 3 4 5 6, which is the solution of the given question. Next, write example number 3. Write the set A is equals to, they given in a roster form. We have to write in a set builder form. The elements are given in a flower bracket, and in between the elements there is a comma. So it is of the form, in the form of list or tabular. That's why it is in presence of roster form. We have to make in a set builder form. Okay, first we have to check the numbers. There is a common characteristics here. Here 1 can be written, and here 1 4 9 16 25 up to so on. Therefore 1 can be written as 1 square. Okay, then 4 can be written as 2 square. Again 9 can be written as 3 square. 16 is 4 square, that is 5 square. Up to so on means there are the natural numbers square. Okay, here 1 2 3 4 5 are natural number. Here they are in the form of square. Therefore then the common property is, here it can be written as A, it is equals to a set. The elements can be written as x, such that x is equals to, okay, x is x such that x is equals to x square, which is belongs to n. Okay, this is the common method of the set builder form. It means whatever the, okay, whatever the element of x we have taken here from natural number, the elements, one is taken as x, then one condition is 1 square, that is 1. Here I consider x is equals to 2, then 2 square is 4. For up to the given, up to so on, for any natural number we have taken, that can be written in a x square form. Or sometimes it can be written another one form, that is equals to A is equals to, or it can be written as the it can be written as the set A is equals to x is a square of natural number. Okay, x is x such that x is a square of X is a square of natural number. X is a square of natural number. Okay, it can be written as x is a square of natural number. Okay, this is the set builder form. Now we have to discuss the exercise problem. Here the exercise 1.1. Okay, first question, exercise 1. Which of the following are sets? First we have to check the sets. Okay, justify your answer. The first question is the collection of all the months of the year beginning with the letter J. What are the how many months in a year? There are 12. Okay, there are 12 months in a year. Here they given the collection of all the months of the year beginning with the letter J. Okay, uh, that is the month beginning with J is January. Okay, next June and July. Okay, the month is June, July, January. Okay, then it can be calculated. Okay, okay, therefore the month starts with JR 3. Okay, there are 3 months in a year. The month beginning with the letter J, therefore it is a well defined. That's why the collection of all the months of a year of beginning with the letter J is a set. Okay, then it is a set. Next, another one, the collection of 10 most talented writers of India. It is set? No, because most 10 most talented writers, there are so many talented writers of India. Okay, there are so many writers are there. For example, mm, Kuempu. Okay, Kuempu was an Indian. Then Chandrasekhar Kambar, Prem Munshi Premchand. Then some of the greatest talented writers are there, but 10 most we can't say. Okay, we can't say accurately because so many writers are there in India. That's why it is not a well defined, not set. Okay, because our definition says well defined, but the most talented writers are not defined accurately. That's why it is not a set. Next, a team of 11 best cricket batsmen of the world. Here they consider world. Okay, in world so many best cricket batsmen are there. Okay, because we know that my favorite Dhoni. Okay, and there are best cricket batsmen are Virat Kohli in our India. Virat Kohli, Sachin Tendulkar, Kapil Dev, so many cricketers are, but we can't say particularly team of 11 best cricket batsmen of the world. In the world, so many best cricketers, batsmen are there. Um, Mr. ABD and so many of the cricketers are there, but exactly we can't say. It is not a well defined. Okay, the cricketers are not a well defined collections. Okay, that's for it is not a set. Next, the question number 4, collection of all the boys in your class. Okay, we can say the collection because okay in our class. Okay, in our class, for example, there is a strength of 50 students. There is a 30 boys, 20 girls. Okay, we can easily sort out boys and girls in our classroom. That's why it is a well defined set. Okay, write your strength, class strength of boys. Okay, here you have to write your class strength of the boys. Then the collection of all the natural numbers less than 100. Okay, the natural number starts with 1. Here the collection of all the natural number less than 100. Okay, the set is, that is the set A is equals to Number starts with 1, 1, 2, 3, up to so on. For less than 100 means the last number is 99. From 1 to 90, the numbers of the natural numbers 1 to 99. Okay. Then a collection of novels written by the writer Munshi Premchand. Okay. Munshi Premchand was an famous Hindi writer. Okay. Then we can easily collect their novels. Okay. We can for any particular man. Okay. For any particular writers, we can easily count their novels. Okay. There are 8 novels. Okay. There are 8 novels written by the Munshi Premchand. There are 8 novels. Okay, there are well defined because we have considered a particular writer, we can say well defined. Okay, then the collection of all even integers. Okay, the collection of all even integers. What are the integers? The number starts with 0 and it containing a positive, negative, even and odd numbers. Okay, here there is a collection of all even integer. It means the set z plus. Okay, even integer means then 0 plus or minus 2 plus or minus 4 plus or minus 6 up to so on. Okay, so many we can collection. Okay, we can consider. Then the collection of questions in this chapter. Okay, we can easily say that the collection of the questions in the chapter. Okay, it is a set. This is also set. Next, a collection of most dangerous animals of the world. We can't say the most dangerous animals. Some of the dangerous animals, okay, dinosaurs, lion, tiger, okay, so many most dangerous animals well known, or some of there are not known to us. Therefore, we can't say it is not a well defined. That's why it is not a set. Okay. Next question. Here there is a question number 2. In that question, there are some questions are there. Okay. Here, let there is a question number 2. Let A be a set containing the elements 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs or not belongs in the blank space. Here they given a set A. Okay, the 5, the element 5 which is belongs to set A. Okay, 5 is there. Therefore, we can write the symbol belongs. Here an element 8 which is not present in the set, that's why it is not belongs. Here there is an element 0 which is also not belongs because 0 is not there in set. The element 4 which is belongs to the set, that's why I written. Again 2 is also belongs. Then element 10 is not belongs to these sets, therefore it is not belongs. Okay, then there is a question number 3. Write the following sets in a roster form. Okay, write the following sets in a roster form. Roster form means we can written in a list. Okay, here A be a set, x, the elements of x, they are integers, and the condition is the integers are in between -3 and 7. Here -3 is not included. In between -3 and 7, that is -2, -1, 0, 1, 2, 3, 4, 5, 6 up to 6. Next, second question. Okay, here B be a set x such that x is a natural number less than 6. The natural number starts with 1. Here the number less than 6. Here there is a condition. There is a natural number less than 6. Okay, up to 5. 1, 2, 3, 4, 5. Next, question number 3. X such that x is a 2-digit natural number such that the sum of its digit is 8. Okay, here we have to consider 2-digit number. 2-digit numbers means there are two numbers. Here one is in a 10 place and another one is unit place. Here unit place and it is 10 place. Therefore these numbers are called as a 2-digit numbers. Here we have to consider the two numbers, their sum. Okay, when we add the digit sum we get the value 8. Okay, here I have considered the 2-digit 1 7. Okay, 1 and 7 are 2 digits. When we add 1 and 7 we get 8. Again 2 6. When we add we get 8. Next 3 5. Again 4 4. Next 5 3. Next 6 2 and 7 1. And another one is 8 0. Okay, these are the 2-digit natural numbers. The sum of its digit is 8. Okay, here 8 is a 2-digit number, then we add we get 8, but 0 is not natural number, that's why we can't consider 80. Okay, we can't consider the number 80. There are 7 numbers. Okay, there are 7 numbers of 2-digit natural number. Their sum will be 8. Clear? Then question number 4. X is a prime number which is divisor of 60. Divisor of 60 means what are the number multiplied we get 60. Okay, that is divisor of 60 is 2 3 and 5. Okay, 2 3 5. These are the divisors of 60. And they here there is a 60. 60 can be written as, here 60 can be written as 2 into 3 into 5 into 2. Okay, we get 2 3s are 6, 6 5s are 30, 32s are 60. These are the divisor of 60. Okay, these are the divisors of 60, but they say prime numbers. 2 3 5 are prime numbers, therefore the set of numbers 2 3 5. But another one too is a whenever we have to written in a set form, they can written in only once. All the numbers are written in once, therefore 2 not written another times, it becomes 2 3 5. Okay, then here x, the set of all the letters in the word trigonometry. Okay, the is, sorry, here I am written small letter, but in question they are written in a capital letters. Okay, here we can list out. First T R I G N O M E. Okay, T already written, so left it. R also already written, then 1. Okay, this is the roster form. Then the last question, set of all the letters in the word better. Set of all the words in the letter better. Okay, that is F is equals to B E T, again T written, E also written, then R. Okay, these are the elements of the word better. Okay, next there is a question number 4. Okay, there is a question number 4. Write the following sets in the set builder form. We have to written in a set builder form. Here we can consider. Okay, here we can consider the question 3, 6, 9 and 12. The elements are 3, 6, 9, 12. What is the general characteristics of these terms? 3, 6, 9, 12. Okay, 3, 6, 9, 12 are the numbers which is present in 3 table. Okay, 3 table. That's why I written set A is equals to an element x. X is a multiple of 3. I can written is multiple of 3. Okay, here multiple of 3. 3, 6, 9, 12. But there is only 4 numbers. Okay, there are only 4 numbers. They are written, therefore multiple of 3. Then x is less than 5. Okay, x is less than 5. Here I am consider 5 because 5 is not less than 5, means there are 4 numbers. X is less than 5 and another one condition, x is a natural number. Okay, x is a natural number. Okay, here x is a multiple of 3. Okay, x is less than 5, or you can write x is natural number. Okay, here from natural number the multiples are the natural numbers, there are 1, 2, 3, 4, only 4 elements. One multiple of 3 means 3 into 1 we get 3, 3 2s are 6, 3 3s are 9 and 3 4s are 12. Okay, this is the set builder 4. Here check the second question. Here also 2, 4, 6, 8, 16, 32. You can observe. Okay, here you can observe, sorry, in question 6 not there. 2, 4, 8, 16, 12. Okay, these are the numbers. Okay, what we written? Okay, here when we multiply 2 into 2, 4, 4 to the 8, 8 to the 16, 16 to the 32. So I have written, generally I am written here x is such that x is equals to 2n. I can written. Okay, then the condition is satisfied when 2 into 1 2, again 2 2s are 4, 2 3s are 6, but 6 not, it is not our set builder form. Other than what can be written? Okay, what can be written? Think. Here we can say that 2 into 4, 4 8s are. Otherwise, sometimes it can be written as 2 to the power 1, 2, again 2 square is 4, 2 cube is 8. There is a relation. Okay, here x such that x is equals to 2n. Okay, when we take the power 1 we get 2, again 2 to the power 4, 2 3, 2 to the power 3, it is 8. So that I can written as n is belongs to the natural number. Here only 5 numbers, that's why I consider uh, x is less than 6. Okay, x is less than 6. We can written it as x is less than, because only 5 numbers are there, that's why I am written x is less than 6. Next we have to choose. These are the 5 square, 5 5s are 25, 25 5s are 125. Otherwise we can write 5 to the power 1 5, 5 square 25, 5 cube 125, 5 to the power 4 it is 625. Similar property of to question number 2. Here I can return x is equals to 5 to the power n. Again n is belongs to the natural number because the powers are we have taken 1 2 3 4. That's why I have written natural number. Here only 4 numbers are, therefore I have written x is less than 5. Okay, next here I have considered 2 4 6 up to so on. There is no end here, that's why I have considered x such that x is equals to 2 into n. We have taken n is equals to 1. Here taken n is equals to 1, 2 into 1 we get 2. Again n is equals to 2 we get 4, n is equals to 3 we get 6. Whatever the we multiply taken as n we get answer. Therefore x n is a natural number. Here there is no end, that's why we can't write these condition here. These type of conditions is in this question. Okay, here next one is 149 up to so on 100. Here there is what is the common relation where we see the numbers 149. Okay, here 1 square is 1, 2 square is 4, 3 square is 9, then the last number 100. 10 square is 100. Okay, that's why I am written here, but only 10 100 numbers, the squares of natural numbers. 1 square is 1, 2 square is 2, 3 square is 9, 4 square is 16, 5 square is 25, 6 square 36, 7 square is 49, 8 square 64, 9 square 81, and 10 square is 100. Okay, here from 1 to 100 all the numbers are there, that's why I am written x such that x is equals to n square. For every n is the natural number and the natural then there is a x. Okay, x is less than 11. Okay, here the condition is I have considered x is less than 100 because when we consider 11 the 11 square is 121. Okay, here 121 is not there, so up to this much this is obeys the condition. Here there is a fifth question. List all the elements of the following sets. They given a condition, it means they given condition in a set builder form. We have to write the elements. The condition is x is an odd natural numbers. What are the odd numbers? Natural numbers means starts with 1. Okay, there is no end, therefore the odd numbers 1, 3, 5, 7, 9 up to so on, because they are not given end condition. Here x is an integer. Here there is a condition, the numbers from -1 divided by 2 to 9 by 2. Here we have to neglect divided by 2 on both sides. First have to neglect it, so I return the elements -1 from +9. Here -1 0, next 1 2. Here less than -1 means this -1 is not included. From 0 1 2 3 4 5 6 7 and 8. Okay, now from -1 divided by 2 to 9 by 2 the elements are there, so here I have written 2 on each, divide by 2 on each element. Okay, then it is written in another one, 0 by anything it is 0. Okay, here 1 by 2, then 2 divided by 2 it is 1, and 3 by 2 Again 4 by 2 means 2. Next 5 by 2. 6 by 2 means 3. 7 by 2. And the last one is 4. These are the elements which is lies between minus 1 by 2 to 9 by 2. Then the condition question number 3. Here x is an integer, x square is less than or is equals to 4. Here whatever the elements we have taken, the elements are less than or is equals to 4. Here x is an integer means these are the integers containing both positive numbers as well as negative numbers. First, here there is an x. Okay, I have to check. Put x is equals to plus 1. 1 square is 1, which is less than 4. Okay, it is obvious. Again, I have considered minus 1. Okay, minus 1. Minus 1 square is again 1. Okay, the value 1. The condition is obvious. Now I consider the 2. Okay, plus 2. 2 square is 4. So 4 is less than or 4 is less than or is equals to, there is equal, 4 is equals to 4. Okay, obvious. Again I consider minus 2. Minus 2 square is again 4. Now I consider an integer 3. 3 square is positive 9. 9 is not less than or is equals to 4. Okay, that means there are the integers are only plus or minus 1, plus or minus 2. Only two integers having or obeys the condition. Next, the last question. Here the next question is x is a letter in the word loyal. Okay, here we have to write the letters of loyal. L O Y A and L. L already written, so L O Y A. Next, X is a month of the year not having 31 days. Okay, here X is a month of year not having 30 other than 31 days. What are the months? January, it is 31. Okay, January. Then the February month having the days 28 or 29. Next, March 31st. April 30. Okay, April containing 30 days. May 31 days. June, May, June 30. July 31. Okay, next June, July 31. Next August, August also 31. August. September 30. September 30. Next September, October 31st. November 30. Okay, November 30. Only 5 months containing other than 31 days. Next question. X is a consonant in the English alphabet which is precede K. Precede K means before K. What are the consonants before K? Okay, the list of consonants are F is equals to B. Here the vowels are A, E, I, O, U. These are the vowels. Okay, these are the vowels of the, here these are the vowels of the English alphabet. Other than these and also before K, precedes means before. B, C, D, F, G, H, J. Okay, J, next letter is K. They given precede K. Okay, therefore the consonants are B, C, D, F, G, H, J. Okay, these are the solutions. Next, there is a last question, question number 6. Match the following. Here one of the elements they given, the here A list and this is B. Here A, the elements are written in a roster form. Here in B, the elements are written in sets are can be expressed in a set builder form. Okay, here 1 2 3 6, 1 2 3 6. Check. Prime number? No, 6 is not a prime number. 2 and 3. Here x is an odd natural number. No, 2 and 6 are not odd numbers. Again, x is a natural number and divisor of 6. Yes, here the condition is obeys. Okay, that is x 1 2 3 6 are the divisors of 1 2 3 6 are the divisors of 6. Okay, and the first one is related with c. Next, 2 3 checks x is a prime number and divisor of 6. Here they given prime number 2 and 3 are prime numbers. Okay, they are also divisor of 6. Next, mathematics. Okay, this is the solution. 1 3 5 7 9 are the odd natural number less than. Okay, these are the solution of the questions. Up to this much, the exercise 1.1 is completed. If you if you really like my channel, please subscribe and share to those your friends which is helpful for them. Okay, thank you.